The first formula is for the derivative of the sine function. This one's pretty easy. So the derivative of sine x, It turns out that the derivative of the sine function is just cosine. So it's just cosine. So you just memorize it. Derivative of sine is cosine. This is one of the things you remember, like when you're done with the course, because you do so much of this, you know, like it stays with you, maybe even for the rest of your life, like maybe even after you've, you know, when you're 80 years old, you might still know this, right? I mean, maybe. That would be great. And then take the derivative, it's really cool, right? Derivative of cosine. This one is super annoying. It may not seem that way, but when we get to integration, it's just one of those things. I wish it wasn't, but it is. This is negative sign. So it's got a negative sign. Oh, it's got a negative sign. Huh, get it? Yeah, negative sign. That wasn't on purpose. That's so dumb. Yeah. The derivative of cosine is sine, but it's got a negative sign. It's ridiculous. So that's the formula. Do you get it? Negative sign? Yeah, that's really bad. It's just terrible. It's so bad. Okay, whatever. dtx. The derivative, how about tangent? That's another popular one. So I'm trying to do like the most popular ones. Derivative of tangent. This one is secant squared. So secant squared x. Secant squared x. A very popular derivative. You can ask, like, any Calc 2 student will know this. Like, it's one of those things. You become a master at this. And then the derivative of secant is secant tangent, right? Secant tangent. I was teaching Calc 2 many years ago, and I had a student from Russia, and he told me that in Russia, he said, in my country, that's how he said it with a cool accent, in my country we do not use these functions. I don't know if that's true. But yeah, so he had all these formulas memorized in terms of sine and cosine. Like he had it memorized as the derivative of sine over cosine is 1 over cosine squared. That's how he had it memorized. He withdrew though. After the second test, he just, nice guy though, but yeah. He had a really cool accent. It's like, in my country, we do not do such things. I'm like, whoa, all right. It's like, back up, like, sounding really hardcore. So interesting, right? And then, so these are the ones that come up the most, right? These are the ones you'll probably be able to memorize, and I'll give you some hints for memorizing them. These last two are the worst. So the derivative of cotangent is negative cosecant squared. Okay, negative cosecant squared. And last but not least, or last and least, the derivative of cosecant x is negative cosecant cotangent. You might say, I'm never going to memorize these. You will, eventually, right? It'll take a lot of work, but eventually you will. You got a couple weeks till the next test. I mean, these are the ones that throw people off on tests sometimes. I usually put a question on there where, like, it's a really easy derivative. Like, find the derivative of cotangent plus cosecant, go. Like, so it's all about, do you know the formula, right? So sometimes some people will get it wrong. But they don't come up a ton, right? These come up more. So a couple things to notice. Yes! I was about to say that. Good, Selena. All the C's are negative. So if it has a C, it's negative. If it has a C, it's negative. If it has a C, it's negative. So if it has a C, it's negative, right? Yeah, it's pretty useful. I've never used that. I had a student who used that before, and it worked for him, right? So he got an A. And so all the C's, yeah.
Why do they equal if they equal?
You have to prove each one individually. Yeah, it's a good question. I mean, you could think of like this one as the slope of the graph of the tangent function gives you the cosine. Like if you graph all the slopes, think about this. The derivative is the slope, right? This should be correct. So if you look at the derivative of sine, it's the slope of the sine function at every single point, like slope, 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 slope. So you look at the graph of all the slopes, and you get cosine. It's pretty deep. Yeah. I just thought of that now because you asked, but the other ones are the same, and you could derive them. So all the C's have negatives. This one's pretty easy to memorize. This one's annoying. Notice that if you have the derivative of tangent and cotangent, so you get the cont functions, right? You get secant squared, negative cosecant squared, right? You get those weird functions. Also, the derivative of secant and cosecant, they appear in their own derivatives, right? See? Isn't that interesting? So the cant functions appear in their own derivatives. So the derivative of secant is secant tangent. The derivative of cosecant is negative cosecant cotangent. So they appear in their own derivatives. So, and the derivatives of the and functions, whatever you have, tan and cotan, have the cant functions. So, yeah, eventually you just memorize them though.